Did it ding? Probably. All right, today's lesson, we are covering quadratic applications. So we are going to solve quadratics from word problems. So we're going to use all of our skills in the last 3 lessons with solving square roots, solving factoring, and solving with the quadratic formula. I'll do an example of each application problem where we can solve with every method we've learned. All right, on your problems, on your homework, you can decide on what you're going to use. Remember, quadratic formula works for every type of quadratic problem, but just not the most efficient way. Okay, so our first example, Jennifer hit a golf ball I'm going to say where, just to shorten up how this is described so you don't have to write as much, where h of t equals negative 16t squared plus 100t is the height of the ball after t seconds. Okay. So that's our situation. You're always going to be given an equation. You need to pay attention to what the equation means. So when I plug in a time, I get back out the height. All right, so now we're going to have a few questions here. So we did problems like this before. So if I say find the highest point, the golf ball reached. Right here should be a review from a few weeks ago. If I'm looking for the highest point on this parabola, what does that mean I'm finding? That would be the vertex. So that means I need to use negative b over 2a. Coming back to this, good news. So my b would be 100, so negative 100 over 2 times my a is negative 16. So negative 100 divided by negative 32 would come out to be 3.125. And remember, that's that input for your vertex, so that's going to represent my time in seconds. Okay, so if I want the actual highest point, I will need to plug that back in for t. In my function. Okay, so you'll type that in your calculator like we did in the past, and then this will give us the height. I don't think I said in what unit, but it should be in feet. So that will come out to be 156.25 feet. All right, so that's nothing new, but it's been a while since we've talked about negative b over 2a. So what would be kind of a new application problem would be, when will the ball hit the ground? All right, the reason why this part's a little bit new, if I'm asking for when, I'm still looking for the time, right? We want to know that time. If the ball's on the ground, what is my height? 0. All right, so that means I'm plugging in 0 for that h of t, that height, and then I'm solving for t. All right, so I'm finding the 0. So this is like things that we've had to do this past week. We're solving these equations. All right, so then when you get to solving and you plug in your 0, it's up to you to decide how you're going to solve this. I do not have a C. So what I've told you is if you are missing one of those things, like a B or a C, there is an easier way to solve than the quadratic formula. This one would be factorable because I have a T in each, so I would factor at least a T out, or in this case, I would do negative 4T. So then I'm left with 4T minus 25. And we'll go ahead and go to lunch. Okay, and we are back. So we were solving this problem by factoring. So I'm going to set each factor equal to 0. So that time would be 0. I will set my 4t minus 25 equal to 0. So if I add 25 to the other side and divide by 4, I should get 6.25 seconds. Okay, so there's two answers here, but we need to know when the ball will hit the ground. Both of these are in seconds. So if we think about what this means at 0 seconds, the ball would be on the ground. So that's just telling you the ball started on the ground, okay? But after 6.25 seconds, it hit the ground again, okay, if that makes sense. All right, then the last question I'm going to ask you on this one would be, what is a reasonable domain and range? Okay, so we talked about domain and range when we first graphed our parabolas. Domain was always all real numbers until you hit a word problem, okay? Because I can't plug in any time I want. I can't have a negative time. I can't go past 6 seconds, otherwise my ball goes underground, technically, graphically. Okay, so typically we like to make a little sketch of what's happening, and that'll help us with our domain and range. So remember, domain is all of the possible x values, and range is all of the possible y values. Okay, so this ball started on the ground, and then it goes up and comes back to the ground again. Right, we know this is at 0, and this is 6.25 seconds, because that's what I just found out. Those are my two x-intercepts. All right, so that's my domain. All of the x values between 0 and 6.25 seconds is when the ball is in the air. So we'd write that t cannot go over 6.25, but should stay above or equal to 0. Okay, for my range, those are all the possible y values. So that I'm going to use h for height. It's also between two numbers. So 0 is the lowest it could be because that's the ground. We're not going below ground. And then I need, well, what is the highest point it could be, which we already figured out. Right? We had to find the vertex of this graph in the first problem. So here is my time, and here is my height. So that was at 156.25, where your x is 3.125, if I remember correctly. Yes. All right, so then I've got 0 and 156.25. All right, in Math Excel, you're not going to have to make a sketch of a graph. On your paper test, we're going to have you sketch one word problem. Just, it asks you all the information. You just need to show where that is on the graph. All right, you'll find the y-intercepts, the x-intercepts, and the starting, or the vertex. All right, let's look at another word problem situation here. So our second example, the profit From selling tickets depends on the ticket price. The profit can be modeled by the function p equals negative 15x squared plus 600x plus 60. Where x is the price of each ticket. Okay, so that's our situation. I'm going to ask you the same questions as we did before. What is the maximum profit? Okay, if I'm trying to find the maximum, once again, I'm finding that vertex. So I start out with negative b over 2a. My b is 600, so negative 600 over 2 times my a is negative 15. So negative 600 divided by negative 30 will give you 20. All right, and that is my input. That's not the profit. That is the x coordinate of my vertex. So that's the price I need to charge per ticket. All right, if I charge more than $20, it'll be too expensive, so we will not make as much profit because people wouldn't go to whatever we're selling tickets for. If I charge less than $20, I still might get a lot of people going, but it won't be the same as $20 because now it's less amount of money, so I'm not making as much off of each ticket kind of thing. Okay? But I'm looking for the maximum profit, so I must plug in my $20 to my function to find the profit. All right, so once you've calculated that out, really just kind of a calculator problem from there, you should get $6,060 is the maximum profit. Okay. Part B. What price would they have to sell the tickets for to break even? Okay, so to break even means they wouldn't necessarily gain money, but they wouldn't lose any money from what they're spending to make this event or whatever it is run. So that means our profit would have to be 0. So I plug in 0 in for the profit for my function. So one like this, I have an A, a B, and a C. It's kind of You know, we could try to factor if we wanted to. It's got some big numbers. My suggestion would be to factor out a 15 because 15 divides through everything, and maybe we could factor after that. And if we can't, you can still do the quadratic formula, but then you have smaller numbers to plug in. So my personal preference would be to factor out negative 15 is probably what I would do. So then I get a positive x squared minus 40x, and then minus 4. There's not going to be anything that multiplies to negative 4 and would add to negative 40. That number is too small, so it's not going to be factorable. So we'll go ahead and do the quadratic formula anyways, but you can still factor this number out and now use my a as 1, my b as negative 40, and my c as negative 4 instead of using the negative 15, 660. You get the same answer either way, but we're dealing with far less or far smaller numbers. All right, so we'll go ahead and do our quadratic formula here. My b is negative 40, so I will use positive 40. Then I will take 40 squared minus 4 times my 1 times my c is negative 4, all over 2 times my a. So 40 squared would give me 1600. 4 times 4 times 1 would be 16. I have a double negative here, so I'll end up adding 16. So 1,616 over 2. All right, so this is going to be my exact form, but when I'm doing word problems, I'm going to want to be decimals. I don't want to say, well, the price I should charge is 40 plus the square root of 1,616 divided by 2. That would be a silly price. We want this in dollars and cents, okay, for it to make the most sense to reality. So then we'll go ahead and calculate this. So I do it one at a time. So I've got 40 plus the square root of 1,616 divided by 2, and 40 minus the square root of 1,616 divided by 2. Make sure if you're doing that in your calculator, if you are doing that all at once, you must put parentheses around this before you divide by 2. Otherwise, your calculator will only divide your 1,616 number by 2 and not the whole thing. All right, typically what I do is I take 40 minus 1,000, the square root of 1,616, I press enter, and then I divide by 2. Okay. One of them, this one, will come out negative. So it doesn't make sense to charge a negative price. That would be dumb. Okay. So this will not be an answer that we would use in our problem. It's an answer that falls on your graph, but does not make sense. Okay? This one should come out to be $40.10. Okay, so that's what they should charge. Last question I will ask is, what is a reasonable domain and range? So we'll do a quick sketch of the information that we already found out. So the domain is going to fall across the values on my x-axis. So we're not going to charge any negative values. So my price was X. We can't go over the price to break even, otherwise we go negative. So it's going to end at that $40.10. All right, and then we also have to charge something. I mean, technically you could say, oops, I need a symbol between there. You could say it must strictly, X must be greater. I could have people would argue who wouldn't put the equal to, because you're not going to charge nothing. It's not going to be free. So you can make that argument if you'd like. I won't be too picky about which sign you chose for that. This time it's not going to cross at 0, 0 because we're not starting at 0. You had that like negative 18, so that's where it's going to cross here. But that part of my graph will not be important for this problem. Only once we get to 0 would it be important. Okay, for my range, all right, my y, this was, I think I had it as p, so we'll do p. Profit will be between 0 and the maximum value that we found to be from part A, $6,060 was the top. So we will not go over that. Okay. All right, we'll end with that. I had one more problem that you can use solving square roots, but we're just going to ask the same questions over and over again. So you're going to have problems will ask you find the maximum or minimum. So you're doing that negative b over 2a, or you're plugging in 0 for the output, and you're solving with factoring, quadratic formula, or square roots when you can. All right, so that'll be it for our lesson.